Welcome back, and in this lesson I want to start off by covering an important part of how AWS handles security. And I want to talk about IAM policies in this lesson. IAM policies are a type of policy which get attached to identities inside AWS. And as you've previously learned, identities are IAM users, IAM groups, and IAM roles. Now you'll use IAM policies constantly. You'll need to understand them for the exam, as well as if you design and implement solutions inside AWS. Policies, once you understand them, are actually pretty simple, so I want to step you through the components and give you an opportunity to experiment with them inside your own AWS account. Understanding policies comes in three main stages. First, you'll need to understand their architecture and how they work. Second, you need to gain the ability to read and understand the policy. And then finally, you'll need to learn to write your own. For the exam, understanding their architecture and being able to read them is enough, so that's what I'll be focusing on in this lesson. You'll gain the ability to write them as you work through the course and get more practical exposure. So let's jump in and get started. An IAM identity policy, or an IAM policy, is just a set of security statements to AWS. It grants access or denies access to AWS products and features to any identity which uses that policy. Identity policies, also known as policy documents, are created using JSON. So it will help a lot if you've already experienced JSON before. If not, don't worry, it'll just need a little bit more time and effort. This is an example of an identity policy document, and this is the type of thing that you would use with a user, group, or a role. At a high level, a policy document is just one or more statements. So inside this statement block, there are multiple statements. Each of them is inside a pair of curly braces. And it's these statements which grant or deny permissions to AWS services. When an identity attempts to access AWS resources, that identity needs to prove who it is to AWS, a process known as authentication. Once authenticated, that identity is known as an authenticated identity. AWS knows which policies an identity has, and it could be multiple, and each of these policies can have multiple statements in it. So AWS has a collection of all of the statements which apply to a given identity. AWS also knows which resource or resources you're attempting to interact with, as well as what actions you want to perform on those resources. AWS then works through all of the statements one by one, and it reviews any that apply to a particular identity accessing a particular resource in a particular way. So let's step through what makes up a statement. The first part of a statement is a statement ID, or a SID, and this is an optional field which lets you identify a statement and what it does. See how in this case it states full access. In the second statement, it states deny cat bucket, and that's just a way that we can inform the reader what this statement actually does. It's best practice to always use these, regardless of how big or small a policy document is. Every interaction that you have with AWS is a combination of two main things: the resource that you're interacting with and the actions that you're attempting to perform on that resource. So an example might be that you're attempting to interact with an S3 bucket, and the action you might be attempting to perform is to add an object into that bucket. A statement only applies if the interaction that you're having with AWS matched the action and the resource. The action part of a statement matches one or more actions. It can be very specific and list a specific individual action. The format is service, and then the operation. So S3, and then the operation is an example. Or, as shown on screen, you can use wildcards. So a wildcard can match any S3 operations if it's listed in the format S3, Alternatively, actions could be a list of individual actions. So you've got three options. You have a specific individual action, a wildcard, or a list of multiple independent actions. Now, resources is the same, only it matches AWS resources. Now, you can use wildcards here too, so specify individual AWS resources, or you can specify lists of AWS resources, as with the second example. Now you can use wildcards to refer to every resource, but if you do refer to either individual resources or lists of resources, you use the ARN format or Amazon resource name, and I'll talk in a little bit more detail about that in the next lesson. Now lastly, we have effect, and effect is either allow or deny. Effect controls what AWS does if the action and the resource parts of a statement match the operation that you're attempting to do with AWS. So if you're attempting to access an S3 bucket and the action and resource part of a statement match and the effect is allow, then AWS will allow you to access that resource using those actions. If the effect is deny, such as the one that's highlighted now, then if you're attempting to perform an action on a resource, it will be denied. Now, it is possible that you could be allowed and denied at the same time. So take this example that's on screen now. Imagine that you're attempting to access either the cat gifts bucket or an object in the cat gifts bucket. Well, the top statement will apply because that matches any S3 actions on any resource. So if you're attempting to access the cat gifts bucket, it will apply and it will allow that access. But the bottom statement denies any S3 actions on a specific S3 bucket. Understanding policies where there's only one allow or one deny is easy because there's no overlap. The challenge is when you do have this overlap, and you'll fairly often see questions related to this in the exam. So let's take a look at that in more detail. For this example now, let's assume that an identity is attempting to access an object in the cat gifts bucket, and that identity has this policy attached to it, so the one that's on screen now. Visually, we can show this as a Venn-style graphic. The first statement is pretty wide. It allows full access to all of the S3 service. It's all S3 actions on all resources. So with this statement on its own, you could access any object in any bucket in S3. You could perform operations on any object or any bucket, or even create and delete buckets. Essentially, with this statement, you're an S3 administrator. The second statement denies access to a small portion of S3. In this case, it's the cat gifts bucket and any objects in that bucket. One of the most important security concepts in AWS for the exam and for the real world is how to handle this overlap style situation. If there are multiple statements which apply to an operation in AWS, as with this example, then both of the statements are processed. So in this case, you're both allowed access to all of S3 and denied access to this specific bucket. Now luckily there are a set of consistent rules which make things pretty easy to remember. If you remember the rule, it'll always make sense. We start with the first priority. The first priority are explicit denies. What that means is that if you have a statement which explicitly denies access to something, then that's it. It wins. It overrules everything else. The policy denies access to a particular resource and action combination, and nothing can overrule that. In this example, accessing the cat gifts bucket or any object in that bucket is explicitly denied. That's it. Nothing can overrule that. The second priority are explicit allows. And in this example, this statement explicitly allows access to all S3 actions on any resource. And these take effect unless, and this is the really important part, unless there is also an explicit deny. If you're explicitly allowed access to something, which the top statement does, and you're also explicitly denied access to something as the bottom statement does, the deny always wins. Explicit denies always take priority. Lastly, if neither of those applies, or if you're attempting to do something for which you have no explicit allow and no explicit deny, then the default implicit deny takes effect. With the exception of the account root user, AWS identities start off with no access to any AWS resources. It's really important for you to understand this. If they're not allowed access, they have no access. Get used to repeating this rule. Deny, allow, deny. Say it while cooking, while cleaning, while working out. Even try to say it while you're sleeping. Just this one rule will mean that you can answer questions much quicker in the exam. It's the same rule if one statement applies or 10. If one policy document applies or 10, it doesn't matter. If there are no allows which apply to a specific action on a particular resource, then you have no access. If there is an explicit allow, then you do have access unless there is an explicit deny. If you have an explicit deny on anything, that always wins. So the rule is deny, allow, deny. Now it can be more complex because there might be multiple policies involved. Take Sally for example. She's a developer and she's trying to access a resource inside AWS. Sally has two policies which apply to her, policy 1 and policy 2. But Sally is also a member of a group. That group is called the developers group. So she's a member of that group, and that group also has a policy associated with it. So Sally attempts to access an AWS resource, and that AWS resource might also have a policy associated with it. All of these policies will have one or more statements inside them, and the way that AWS handles this is when a given identity accesses a resource, it collects all of the statements in all of the policies which apply, so the users directly, the groups the users are in, and any resource policies on the resources that they're attempting to access. It collects all of these together and evaluates them all at the same time. But the same rule applies. Deny, allow, deny. If there's ever an explicit deny, that's it, game over. If there's an explicit allow, then you're allowed access unless there is a deny. And if none of those apply, there is always the default implicit deny. Now there's one more thing I want to cover before I finish up this lesson, and that's that there are two main types of policies, inline policies and managed policies. Now they're the same thing, they're JSON policy documents, the difference is how they're managed. Let's say we have 100 staff in our business, and of these 100 staff, we're going to use an example focusing on 3. We've got Sally from the previous example, and she's a developer, Miles in accounts, and Mike in production. So let's say you're running a secret project and you want to grant these 3 access to the resources for that project, then you could do it in one of 2 main ways. First, you could design a policy that grants access to the resources needed for that project and then assign that JSON individually on 3 separate accounts. Now that's known as an inline policy. Crucially, what you're doing there is you're applying the JSON to each account individually. It becomes 3 isolated bits of JSON. Now this would work in this situation, but it's not best practice. Because it's 3 individual inline policies, each of which is an individual piece of JSON, changing the access rights would mean changing it on all 3 of these inline policies. Doing this for 3 staff might sound easy, but what about 300? And then if you needed to change the policy that's applied to those 300 staff, well, you'd have to edit 300 inline policies because they're unique to each identity. Another option is to use what's known as a managed policy, and managed policies are created as their own object. First, you'd create the managed policy, which is just a piece of JSON with some statements in, and then you'd attach that policy to any identities who you wanted to gain those access rights. Now, managed policies are great for 2 main reasons. First, they're reusable. So in this example, I can use the same managed policy for 3 identities or for 300. So for access rights that you want to grant to large numbers of users, groups, and roles, you should definitely use managed policies. Managed policies should be used for the normal default operational rights in your business. So if you've got a set of common access rights that you want to give to lots of people, then you should use managed policies. Now, secondly, managed policies are low management overhead. So if you do need to change the JSON in a managed policy, then it immediately impacts all of the identities it's attached to. So the question is, when would you use an inline policy? Well, generally, this is for exceptions to the normal access rights that you want to grant. So special circumstances, exceptional access rights, when you need to ensure that a specific set of rights, either giving an individual more access rights or blocking certain permissions for one individual identity, then you can use inline policies, apply those to one particular user, and then influence the permissions on that user. So generally when you're using inline policies, it's for special or exceptional allows or denies. Now there are two main types of managed policies: AWS managed policies, which are created and managed by AWS. Now you don't need to manage these, but they might not fit your exact needs. And then you have customer managed policies, which you can create and manage, so you can define them as per the exact requirements of your business. Now I do want to give you the chance to gain practical experience of how to use these different types of permissions within identity policies in AWS. So elsewhere in this section there's going to be an opportunity for you to gain some practical experience, but initially I just want to introduce the theory. Now at this point that's everything that I want you to do in this lesson, so go ahead and complete the video, and when you're ready I'll look forward to you joining me in the next.